Here's the definition of a linear function. The word line is right in it. A linear function is a function that can be represented on a graph by a straight line. And these, you'll see, you've already seen with some examples on some learning opportunities you've done, that many real-world situations follow linear functions. And so those will be the first functions you focus on in mathematics, starting right now. A linear equation in two variables is an equation in which the variables appear in separate terms and neither variable contains an exponent other than 1. Now that's one of those definitions that's hard to understand when you read it, but easier to understand when you look at some examples. So here's the first example of a linear equation. Two variables, check. I've got x and y. Usually it's x and y. It doesn't have to be though. Two variables, and it's an equation. There's the equal sign. The variables are in separate terms. Now we've talked about terms are separated by addition and subtraction. So here's a term, here's a term, here's a term. The x and the y are in separate terms. They're not in the same term. You'll see some non-examples in a minute. And neither variable contains an exponent other than 1. When I see y, that's not y squared or y cubed, it's y to the first power. There's just not usually a 1 there because that's the default. X is x to the first power. So as long as the exponents are 1 and you've got two variables and they're in separate terms, it's going to graph like a line. This one is also a line. I've got two variables, x and y. They're in separate terms and their exponents for both variables are both 1. This is also a linear equation. Even though it looks different than these others, there's no constant term, but the variables, the x and the y, are in separate terms. Notice they don't have to be on the different sides of the equation either. They can be on the same side. We could manipulate them to put them on separate sides, and we'll work on that a little bit later. But I've got two variables, they're in separate terms, and the exponent on both of them is 1. This one is a non-example because exponent is 2 here. That's actually a parabola. I think I might, yeah, this one would graph like this. It's definitely not a straight line. This one creates what's called a hyperbola, also not a straight line. And this one creates a different looking parabola. Anytime you have y equals something to do with x squared, you're going to see some kind of parabola. It's called a quadratic equation. The reason this one fails for the same reason the first one failed. We've got x to the second power, not to the first power. And this one fails because the variables are in the same term. They're not in separate terms. Linear equations are easiest to graph. I guess that could be subjective, but I believe it's true. When they're written in slope-intercept form, where you have y isolated on one side of the equation, and then your x and any constant terms are on the other side. M is the coefficient of the variable term, and there's a lot to m. We'll get to that a little later this week, and a lot next week. The solutions to linear equations are written as ordered pairs, so x comma y, just like you would expect. You input a value for x, figure out what y is, and that's your y value, and then you've got a point on your line. Yeah, we're going to try that in just a minute. You pick a value for x. You can pick any value you want. Substitute it into the equation, and then you get the output, and then you start to get points on your line. We're going to do this for 3 values of x, and make a table to organize our work, and then we'll be able to graph some linear equations. We'll do the first, let me see. On your notes you have 3 like this, so we'll do the first one together, and you'll try the next 2 on your own. And then of course after each one, I'll have a little video showing or comparing your work to mine. The key to this is picking easy values for x. I think the easiest value I could pick for x would be 0. Because if I substitute, if y equals 3x, and I substitute 0 for x, 3 multiplied by 0 is just 0, so y would equal 0. So when x is 0, y is 0, so the origin is 1 point on my line. You can graph that. The next easiest value for x might be 1. When x is 1, y equals 3x. I just write the equation again, but instead of x, I substitute the value for x that we're inputting into the equation. y equals 3 multiplied by 1, so y equals 3. So 1, 3 is another point on our line, 1 to the right and up 3. Let's do a negative value for x. If x is negative 1, y equals 3x. Y is equal to 3 multiplied by negative 1. So y in this case would be negative 3. So negative 1 as your input gives you negative 3 as your output. So 1 left and down 3. And I think you can see that that would make a straight line. Now I don't want to keep repeating myself, but I'm going to make the best straight line I can on this writing tablet. It's obviously not going to look great. If you have a straight edge, make a better straight line on yours. But if you connect the points, there should be a straight line going through those points. If there's not, we made an error. Go back and check our work. This is the best way to show your work, even when the equations are easy. Write the equation first, substitute the value, and then get your answer. Try that on the next two, and you can check your work when you advance on your pod slide.